Hello! All of the music you'll hear in this video has been generated by computers. However, this isn't AI. These tunes, well, at least the majority, are procedurally generated using special algorithms. The first few, including this one, comes from the Amiga program AlgoMusic, of which I had a lot of fun with when I was younger, as well as a great deal of laughter at some of the funny song names it came up with, of which a handful of these you'll see at the bottom of the screen. In this video, we're going to take a closer look at AlgoMusic, what it does, and a little bit about how it works. We'll learn a little bit about the author and his background, why he made it and what preceded it. Finally, we'll take a look at more state-of-the-art computer music generation. AlgoMusic was the creation of Thomas Schürger, I hope I pronounced that correctly, designed to dynamically create short pieces of music completely generated by the computer, seeded using a random number. To create such a system, you'd require a background in music, and Thomas began having piano lessons at the age of 8. These lessons continued until about the age of 12, after which he only occasionally returned to the piano just to play around. Thomas had developed an interest in computer music, which started with the Commodore 64 using a program called Future Composer Music, an unofficial editor for the Maniacs of Noise Commodore 64 music driver, distributed in the late 1980s. After the Commodore 64, Thomas progressed to the Amiga and enjoyed creating music on Soundtracker, ProTracker and even Octamed, as well as collecting many mod files. In 1995, Thomas started work on the first version of AlgoMusic, and in April he released the first version, with version 1.3 to follow only a month later. By October of 1995, AlgoMusic version 1.4 had been released, which was featured a few months later in the January 1996 Christmas issue of CU Amiga magazine, alongside a copy of Imagine 3. Whilst developing AlgoMusic, Thomas started studying computer science at Saarland University in Saarbrücken in Germany, and continued producing many revisions, with 1.8 being the last of the version 1 releases back in January 1996. So it makes perfect sense that in April 1997 version 2 appeared, and just over 1 year later it reached its final version 2.4 in August of 1998, suspiciously about the time he obtained his first PC. These later versions came with a preferences program, customizable music samples, improved documentation and a workbench installer, but we'll look more at that later. Before we go any further, I just want to give a quick shout out to my Patreon supporters, and if you want to support me in making future videos, then head over to my Patreon page. Now, before we follow what Thomas made next, I think it's actually time to have a play with AlgoMusic, so let's head over to Workbench and take a look. Now, I only happen to have 3 versions, and 1.3 is the first, and I have no idea where I got it from, and I found it in one of my discs from back in the day, so it didn't have any documentation with it at all, and you can see it running here. It's a simple command line utility which, if started without any parameters, will happily invent a song and start playing it. The special number you see here, if you wanted, could be recorded so you could cause the same tune to be generated again. These days, we'd probably call this procedurally generated music, and this is the seed value that's usually fed into some kind of random number generator as a point to start from. Moving on, and this is version 1.4 from the CU Amiga magazine cover disc. And in Workbench we have a nice little icon. I'm still starting it from the command line just so it fits properly in the window. This version comes with an Amiga guide file. And the handy part about it is it's got the version history, so we can see that in version 1.4 we got breakbeat support. Taking a look at the usage information, we can see there's a number of parameters you can pass to fine-tune the type of song generated. You can also get it to replay a previously generated tune by supplying that random init value from the previous run, although I did notice that the same values between different versions of the program produce different songs. You can also change the speed, make it repeat forever, and a whole host of other settings as well. Now, moving much further ahead, we get to version 2.4, which, to make the best use of it, I've installed it to disk. This is the only version that exists on Aminet. Once again, I'm starting it from the command line, but you can see there's 3 icons included. One of them is the documentation, and this time there's a lot more information in there. We've now got so many additional command line arguments it's hard to know where to actually start, and all of them have an effect on the music that's being generated. There's also a developer section, because now you can communicate with AlgoMusic using Workbench message ports, but I'm not going to go into any detail about that. If you happen to have Magic User Interface installed, you could also run the Preferences program that allowed you to play with the music in real time by changing its speed, and adjusting volumes. But you can also configure the features you want to enable by default. These would then be the defaults unless you overrode them using the command line. I even discovered a third-party visualizer for the application, presumably using the included developer documentation to connect with AlgoMusic and react to it whilst playing. And sure, it's quite crude, but it's still cool to see something like this. Now, you're probably thinking it's quite hard to tell the different versions apart from their sound alone. Well, as you might have imagined, not all of the songs it generated were actually that perfect. Most were pretty decent, but to record the songs I used in this video, I had to generate quite a few, and it's noticeable how much more complex and diverse the tunes became with the later revisions of the program. One of the interesting things about the later versions is you could actually add and replace all the sound samples, and I managed to find 3 sound packs specifically for AlgoMusic on Aminet. Now, I was planning a before and after demo with these, but to be honest it just wasn't that interesting. So instead, let's learn a little bit more about the application. Some fun facts. AlgoMusic had quite a number of different built-in pattern sequences for the drums, bass, chords and other effects, and had a large number of pre-programmed chord progressions totaling over 70. Alongside this, the application also had some special pattern sequences for song structure, which included fading in, fading out, the use of speech samples, and other built-in sequences. Thomas still does have the original source code, backed up from his expanded Amiga 1200, that was upgraded with an 030 CPU running at 50 MHz and 48 MB of fast RAM. Whilst not public domain, at least currently, he did share the following facts, and it's made up of around 4,100 lines of C code for the main application. There's around 250 lines of 68K assembler code for the low-level hardware-specific parts such as the CIA interrupt-based player, and also about 760 lines of C code for the Magic User Interface-based AlgoMusic Preface application. Now, I'm no music expert, but I did have a dig around inside the AlgoMusic executable, and there's quite a number of interesting things. The first of which is a list of notes, and there are 70 of them, so it makes me think these are probably the chord progressions. Now, I'm no expert with music at all, but I suspect those 4s and 6s between some of the notes might actually represent flat and sharp markers. The number at the start of the row also seems to make some sense, but I'm not exactly sure what it means. Then there's these number sequences. At first I thought they were related to the melody, but now thinking about it, I wonder if they're actually some kind of percussion pattern or maybe sequences for different effects. The numbers only range between 1 and 4, and I'm guessing the dashes are off or do nothing markers. There's also these sequences, and I have an idea these might actually be the drum beat sequences, but with different symbols representing different styles of instrument. There could also be sequences that play at the end of a section, probably still percussion, but I think I've heard some of these pattern sequences if that kind of makes sense at all. One of the fun parts about AlgoMusic, well, at least for me, was that each song was given a unique and sometimes rather strange or even funny name, and I wondered exactly how that worked. Well, after digging around in the executable, I think I now know. First, we seem to have a list of adjectives, and the list is quite interesting. I wonder what gave Thomas the inspiration for these words. Next, we have a list of nouns, and again it's quite an interesting list. Thirdly, we have a list of names. I wonder if there's any inspiration for these names based on people Thomas knew. The way these work is a random phrase pattern is chosen from the following list, and then the random words chosen from the previous lists are selected, based on the rules, giving you a rather crazy song title. I've colour coded this to make it a little easier to understand. Now, I ran AlgoMusic literally hundreds of times to try and work out which parameters use which sets of data, and I think I've probably got them most right. Interestingly though, these two here never appeared once. I have a suspicion they're disabled because they wouldn't sound grammatically correct with some of the word choices. Interesting, right? Anyway, I'll get back to some history and continuing Thomas's journey. In April of 2000, he finished his diploma and started his first job at a small IT consulting company in Saarbrücken. During this time, he became interested in MIDI and purchased a MIDI master keyboard to experiment with. Now, do you ever get that feeling you haven't quite finished something, like an itch that can't be scratched? Well, I think that must have been true for Thomas too, because in 2008 he started thinking about creating something new, a bit like AlgoMusic but much more flexible. Using his skills in Java that he learnt whilst at the university, Thomas created SoundHelix. SoundHelix is a free, open source Java framework for composing and playing algorithmic random music based on constrained random generation, CRG. You can configure how the sound is generated by using its XML config file system. It uses MIDI to remote control one or several MIDI devices in parallel, as well as the built-in MIDI devices present in most operating systems, to play music back in real time, and has a huge range of features. Everything was carefully explained with extensive documentation, and it was designed to be extendable. As it was open source, you could write your own classes to customize it. During a massive 8-year period, several versions were released, finishing with the final version in 2016. There was even an Amazon Alexa skill available that could play some pre-programmed SoundHelix songs. Would you believe it? That Alexa skill still works too! So go on, get it installed! Sadly, Thomas stopped updating SoundHelix around 2016 due to a lack of interest and, more importantly, family commitment. But he has said he'd like to return to it someday, and would start with a complete code refactor and several improvements. But for now, let's take a look at the last version released. So I'm starting SoundHelix with an actual tune, Popcorn. It's one of the examples that comes with it, used as an input. This is output using MIDI, and it sounds fairly decent. You can see it's generated this grid here, showing how it plans to play the tune. Now what's interesting is watch what happens when I restart the application with exactly the same parameters. See, same tune but sounds different. There's still a nice random element to how this thing works. Now, I don't really have the first clue how to configure this, but there's quite a few examples on the site and they're worthy of a look. I love how both of these songs have been given random names, just like the original AlgoMusic. Awesome. Now, computer-generated music certainly isn't a new thing. I remember watching an episode of BBC's Tomorrow's World, must have been some 30 years ago, where a machine started composing music after analysing thousands of songs. This was of course back in the early 90s, and things have moved on a long way since then, so this brings us up to date with AI. Now, some of you probably don't think of AI as algorithmic. Well, I guess it kind of is, it's just on a much larger scale than what we've seen so far. So, let's take a look at an example. This is Suno.com, not a sponsor. And, well, this is an example of many websites offering AI-generated music. This page shows various styles it can generate music in. It not only creates the music, but it can also write the lyrics and use AI to sing them to you as well. Like most AI tools, you get a box where you can input a prompt to describe what exactly you want. You can also upload your own audio as well. Once we're happy with the description, it will sit processing for a while before spitting out some lyrics and allowing us to listen to its creation. So for this example, let's make a song about the Amiga computer and its amazing Paula chip used to create those nostalgic sounds in the style of 90s pop music.
Dust off the covers of a treasure so hip. In a sea of beige towers, you're the flagship. Clicking keys and loading dreams, a timeless sip. Oh Paula, sweet Paula, you've got the groove grip.
It's okay I suppose. I'll scroll the lyrics a little, but I don't think it's quite what I want. I'm going to change the style to a hardcore dance track and we'll see what we get this time.
Feel the vibe. Retro beats come alive inside. Amiga's magic, it's your guide. Paula sound will blow your mind.
Now that's much better. What's really interesting is the lyrics. This has obviously been trained on quite a large dataset, given it knows about the 64 colour limit, made a connection with floppy drives, tracker files are mentioned, and chiptunes, something I didn't give it any information about at all. It really is crazy what you can generate these days. If you want to listen to the full version of this tune, I'll put a link in the video description, or sit tight, I'll start the karaoke version.
Feel the vibe. Retro beats come alive inside. Amiga's magic, it's your guide. Paula sound will blow your mind. Whoa! Boom, boom, let's go. Paula's the queen. Old school tech makes the future gleam. Bassline kicking a memory dream. Dance to the sound of the retro scene. We're in the zone. Amiga power is the throne. Boom, boom, let's go. Paula's the queen. Old school tech makes the future gleam. Bassline kicking a memory dream. Dance to the sound of the retro scene. 8-bit echoes, they call to me. Tech makes the future gleam. Bassline kicking a memory dream. Dance to the sound of the retro scene. Hey, yo! Let's go! 8-bit echoes, they call to me. To beat in legends, endless spree. Push the limits, wild and free. Paula grooves eternally. Boom, boom, let's go. Paula's the queen. Old school tech makes the future gleam. Bassline kicking a memory dream. Dance to the sound of the retro scene.
Well, there you go. AlgoMusic, SoundHelix and modern AI Suno all rolled into one video. And if you listen carefully, then maybe I shouldn't have been able to create music as easy as this, because this is ridiculous. I want to thank Thomas Schürger for sharing his AlgoMusic thoughts and notes with me as I made this video. It really was very helpful. And if you found this interesting, then make sure you hit that subscribe button so you can be treated to further exciting videos. Thanks for watching, and I'll see you in the next one.